For part A of question 1, we need to find the transformation that gets A onto B. This is obviously an enlargement, and to find the scale factor, just look one of the sides of the triangle. For example, the base, it becomes from 1 to 3, so the scale factor is 3. What we need to find as well is the center. To do so, take any pair of corresponding vertices and join them and see where they meet. So for example, I'll take these two, join them, I'll take these two, join them and see where they meet. As you can see, these two lines meet at the point with coordinates 3, 0, and that's the center of enlargement. So let's write everything down. For part B, I'll need to translate triangle A by the vector minus 4, 3. So I'll have to move these 4 units to the left and 3 units up. So the top vertex will be at 1, 6. So let's draw this triangle. And that's the end of question 1. For question 2, I'll start with 1200 and divide these by prime numbers. So let's start with 2, will give me 600, divide by 2, it's 300, again by 2, 150, again by 2, 75, divide by 3, it's 25, by 5, you get a 5, and then finally by 5 you get 1. So the answer is 2 to the power of 4 times 3 to the power of 1 times 5 to the power of 2. In question 3, I've got 4 numbers. I know 2 of them. I know the median and I know the range. I need to find the 2 missing ones. Now I will consider different cases. Some of these you can do them in your head, but I will write down all my thinking so you can understand how I reach to the final solution. Now, first thing to note is that 158 is less than the median and 175 is bigger than the median. So if the median is halfway between the two middle values, 158 is to the left of this line, 175 is to the right of this line, and I have made 4 scenarios for all the possible combinations. So for the first combination, I'll have 158 to one side, 175 to the other. For the second combination, 158 is the second one, 175 is the third one. For the third case, I've got 158 on the first position, 175 at the third one, and last one, 158 is at the second position, 175 is at the last position. So now I'm going to go through the logic of each case and show why the cases 1, 2, 3 are wrong and why the last one is the correct one. So for case number 1, in this scenario, the range should be 175 minus 158, which comes out to be 17, but in the question we're given that the range is 21, so this case is rejected. For case number 2, I'll work with the median, and the median is 158 plus 175 over 2. This calculation gives me 166.5, but the median should be 160, so I'll reject this case as well. For case number 3, I'll put a D here and a C. For Candela and Diana, I'm given that Candela is higher than Diana. Now if I try to find the median, I'll need to add D plus 175 over 2. This should give me 160, which implies that D is equal to 145, but D should be between 158 and 175. 145 is less than 158, hence this is also rejected. And finally, let's go to case number 4. D is less than C, so they should be in this order. Let's work out the value of C using the median. So median is 158 plus C over 2. This is 160, hence C comes out to be 162, which is between 158 and 175. And also using the fact that the range is 21, this implies that 175 minus 21 will give me D. So D is equal to 154, which is less than 158. Hence, Candela is 162 centimeters and Diana is 154 centimeters. For question 4, might be easy to list the elements of A and B. So A has the multiples of 3 between 9 and 20. Those are 9, 12, 15, and 18. And B has the odd numbers between 9 and 20. Those are 9, 11, 13, 15, 17, and 19. So A intersection B in part I are all the elements that are in A and B. Those are 9 and 15. And in part II, A union B are all the elements in A or B or both. And those are 9, 11, 12, 13, 15, 17, 18, and 19. In part B, it says, is it true that 24 is an element of A? Although 24 is a multiple of 3, in the universal set, we only have elements from 9 to 20. So 24 is not in the universal set, and the answer is no. Finally, for part C, I'm given that C intersection B dash is 10 and 18. Now, C intersection B dash means inside C and outside B. If I draw a small Venn diagram for B and C, this is how it will look like. And in the region of only C, I will have 10 and 18. And C has 4 members, so I'll need 2 more members that will appear in this region. Let's put them X and Y. So this answer is not unique. The answer is basically 10, 18, X and Y, where X and Y are 2 numbers from B, and B are the odd numbers between 9 and 20. So I'm just going to make a note. X and Y are 2 members from 9, 11, 13, 15, 17, and 19. For question 5, I'll use the fact that the area of the square is 36. So x squared is 36. X comes out to be 6. And by x, I am referring to these distances. Now, each of those distances is the diameter of the circle. So radius is equal to 6 over 2, which is 3. So to find the total area, I will add the area of the square plus 2 times the area of a circle, because I have 4 semicircles. If you put them together, you get 2 circles. Now the area of the square is 36. This is given, plus 2 times pi r squared with r being 3. So this gives me 36 plus 18 pi. And if you convert this to a decimal, to one decimal place, you will get 92.5. Note that the mark scheme accepts answers between 92.4 and 92.6. Also note that if you leave your answer in exact form, this is not accepted. You will lose 1 mark. For part A of question 6, I'll start by cross multiplying. So 10p equals 3p minus 5. I'll take the 3p to the left, so 7p is minus 5. So p is minus 5 over 7. For part B, anything to the power of 0 is 1. And then in part C, I'll just rewrite these with larger letters. So I can do various simplifications here. I can simplify the 3 with the 6. I'll have a 2 left. I can cross out the x with the x squared. I'll have an x left. And finally, the y with the y cubed. I'll have a y squared left. So my final answer is y squared over 2x. Finally, in part D, I'll take out a common factor of 5cd squared. And I'll be left with 2c squared plus 3d squared. And that's it for question 6. For question 7, I'll start from the left-hand side and turn everything to a power of 2. So 2 to the k over, and then I'm going to write 4 as 2 squared, again to the power of n. If I simplify the denominator by multiplying the 2 powers, I'll get 2 to the 2n, and then I can write this as a single power by subtracting the powers. So this will be 2 to the power of k minus 2n. Hence, x equals k minus 2n. For question 8, I'll use the following formula. Initial value times the multiplying factor gives me the final value. Now for the multiplying factor, since I have an increase of 12%, the multiplying factor will be 112 over 100, and that's a decimal, that's 1.12. So initial value times 1.12 equals to 1820. So initial value equals 1820 over 1.12. Put this on the calculator and you'll get 16.25. For part B of question 9, I'll use one of the zeros to move the decimal one place to the right. So I get 8, 8, and then the other 5 will be added as zeros. So 1, 2, 3, 4, 5 zeros. So the answer is 8,800,000. For part B, to find the least population, use the smallest number. Now I've got 2 numbers with a power of 6. Out of those 2, this is the smallest one, so Barcelona is the answer. For part C, I'll just do the subtraction of 3.7 times 10 to the power of 7 minus 7.7 times 10 to the 6. You can just put this on the calculator and get the answer of 2.9 times 10 to the 7 to 2 significant figures. If you want to do this manually, you keep the first number the same and change the second one to 0.77 times 10 to the 7. So subtracting 3.7 minus 0.77 will give you 2.9. For question 10, to find angle PAF, I'll find the interior angle of the polygon. and then I will subtract angle PAB. So let's begin. The formula for the interior angle of a regular polygon is the following. In our case, we have a hexagon, so n is 6. So the interior angle is 6 minus 2 times 180 over 6. And this comes out to be 120. Then to find angle PAB, I'll have a right angle triangle. I am given AB and BP to be 5 and 2 respectively. So I'll use the tan ratio. Tan A equals opposite over adjacent. Hence A is the inverse tan of 2 over 5. Put this on the calculator, you'll get 21.8 and so on. So to find the angle PAF, you just subtract 120 minus 21.8, and this will give you 98.2. The mark scheme accepts values between 98.1 up to 98.3. For question 11, I'll plot the upper bounds of age as the x-coordinates and the cumulative frequencies as the y-coordinates. Now the x-intercept will be at the lowest age, which is 10. So if I go to the graph and plot these points, I get the following. And then you can join these points either using a smooth curve or line segments. I'll go with the second one. So that's how the graph looks like. For part B, I need to find an estimate for the median. Since there are 60 people in total, I'll divide 60 by 2 to get 30. So I want the 30th observation. So I'll go on the y-axis, locate 30, and find the corresponding x value. So from the graph, I get a value of 27. The mark scheme accepts answers between 26 and 28. For part C, I need to find the interquartile range. Now, interquartile range is Q3 minus Q1. So first I'll have to calculate Q1 and Q3. Now, Q1 is a quarter of 60, which is 15. So I need the 15th observation. And for Q3, I need 3/4 of 60, which is 45. So I need the 45th observation. So repeat the same procedure as the median, but instead of 30, go to 15 and 45. So from the graph, you can see that these values are 21 and 46. So Q1 is 21, Q3 is 46. So the IQR is 46 minus 21, which gives me 25 years. Mark scheme accepts values between 24 and 28. For part D, I need to find the number of people who are older than 55 years. First, I'm going to find the number of people who are younger than 55 and subtract from 60. So this time I'll start from 55 on the x-axis, go up on the graph, and then on to the left to find the number of people. So I get something about 49. So if I do the subtraction, 60 minus 49, I get a value of 11. The mark scheme accepts an answer of 10 or 11. For question 12, I've got two similar triangles. I'll take the top one, ABC, rotate it 180 degrees, and place it next to CD so you can see them one next to the other. Now, for similar triangles, the ratio of corresponding sides is equal. That means sin D over sin B must be equal to CE over CA. In other words, large red over small red equals large blue over small blue. So let's create our equation. 2x plus 9 over 2x equals to 6 over 1.2. Cross multiply, so 1.2 times 2x plus 9 equals 6 times 2x. Expand, 2.4x plus 10.8 equals to 12x, so 10.8 equals to 9.6x, which means x is 10.8 over 9.6. Now this gives me an x value of 9 over 8. The mark scheme accepts the following decimals: 1.125, 1.12, or 1.13. In question 13, to find the perimeter of the sector, I'll just add the arc A and B, which is this one, plus 5.2 plus 5.2. Now, the formula for the arc length is the following: theta over 360 times 2 pi r. So let's put everything down. Perimeter equals 67 over 360 times 2 pi 5.2 plus 5.2 plus 5.2. Put this on the calculator and you'll get 16.5 to 3 significant figures. Note that any answer between 16.4 and 16.5 is accepted by the mark scheme, but an exact answer that is in terms of pi is not accepted. For question 14, you can think of this as a tree diagram problem, and although you don't have to draw the tree diagram, if you decide to do, it will look like this. Now the probability on each branch is 1 over 2 because half of the numbers are odd and half of them are even, and I want the probability at least one even number. Now, to get the probability, you'll need to add all the combinations that have at least one even number, and out of the 16 combinations at the end, 15 of them have at least one even number. So the only combination that doesn't have an even number is the combination that has 4 odd numbers, and on the tree diagram it's this one. So if you multiply those probabilities, and remember all of those are 1 over 2, you will get the probability that all numbers are odd to be equal to 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 16. Hence, the probability of at least one even is equal to 1 minus 1 over 16, which comes out to be 15 over 16, and that's the final answer. To find the area of the kite, I'll start by joining AC. This creates two identical triangles, and to find the area of one of those triangles, I will use the following formula, which is given on the formula sheet on page 2. So, area of the kite is 2 times 1 over 2 times 6 times 11 times sine of 118. Put this on the calculator and you'll get 58.3 centimeters squared. The mark scheme accepts answers between 58.2 and 58.3. In question 16, I'm given 9 graphs. The first one is the graph of sine, so y equals sine x. Second one is of the form y equals a over x, where a is positive because the graph is in the first and third quadrants. Graph C is a straight line, so y equals mx plus c. Now the gradient is negative, but the y-intercept is positive because it cuts above the origin. Graph D is the graph of tan x. Graph E is a quadratic, so we've got x squared plus various other things. Graph F is a reciprocal function, so y equals a over x, but this time a is negative. G is also a straight line, y equals mx plus c. M is negative and c is also negative because it cuts the y-axis below the origin. H is a cubic, so y equals x to the power of 3 plus other stuff. And I is of the form y equals a over x squared, where a is positive. On the next page, I'm given 4 equations. I need to match the graph for each equation. The first one is a straight line with negative gradient, positive y-intercept. So this is graph C. The second one is a negative reciprocal function, that's f. The tan graph is D. And the last one, if you expand, you'll get x cubed, that's graph H. For question 17, I'll let x equals 0.345, 45, 45, and so on. Now the repeated digits are 4 and 5, and the first set of repeated digits are the following. Now to move the decimal place from here to the beginning of this one implies multiplying by 10. I've got 10x here. And then to move the decimal from here to where the repeating pattern stops, that's 3 positions multiplying by 1,000, so that's 1,000x. Hence, 1,000x equals 345.4545 and so on. 10x equals to 3.4545 and so on. Now I will subtract those two. So 990x equals to 342. So x is equal to 342 over 990, which is equal to 19 over 55 as required. I'll start question 18 by finding the lower and upper bound for the distance and time for each one. So for Kaidan, the distance is between 77.5 and 82.5, and the time is between 2.65 and 2.75. For Sonia, the distance is between 32.5 and 33.5, and the time is between 0.95 and 1.05. Now I'm going to use the fact that speed equals to distance over time, and for Kaidan to be correct, I'll need to find his upper bound and Sonia's lower bound, and if his upper bound is bigger than her lower bound, then Kaidan is correct. So for Kaidan, upper bound equals 2, and then I'll need a large value for the distance over a small value for the time, which means 82.5 over 2.65 will give me a value of 31.13 and so on kilometers per hour. And for Sonia, to find the lower bound, I'll need a low value for the distance over a large value of time. Hence, 32.5 over 1.05 will give me 30.95 and so on kilometers per hour. So I'll just write a conclusion. Upper bound of k, which is 31.13, is bigger than the lower bound of s, which is 30.95. So Kaidan is correct. Question 19, I'll start by first finding f g of x. So I'll just substitute this function into x for function f. So this will give me 2x plus 1 squared minus 4. I need this to be bigger than 0. Now I will expand 4x squared plus 4x plus 1 minus 4 is bigger than 0. So 4x squared plus 4x minus 3 is bigger than 0. If I factorize this, I'll get 2x plus 3 and 2x minus 1 bigger than 0. Now the roots of this quadratic are x equals minus 3 over 2 or x equals a half. Now if you consider a number line or the x-axis and draw this quadratic, you can see that this is above the x-axis for values to the left of minus 3 over 2 or to the right of 1 over 2. Hence the solution will be x less than minus 3 over 2 or x bigger than 1 over 2. For question 20, I'll start by drawing a rough sketch of the circle and the tangent. Now to find the equation of the tangent, I'll use the following formulae. I'll start by finding the coordinates of point P. Now O is the midpoint of AP, so using the midpoint formula, 6 plus x over 2, comma 11 plus y over 2 must be equal to 4, 7. This means that for the x coordinates, I have 6 plus x over 2 is equal to 4, hence x is equal to 2. And for the y's, 11 plus y over 2 is equal to 7, which means that y is equal to 3. Hence point P is 2, 3. Next, I'll find the gradient of the diameter or the radius using any two of the points AOP. I'll use AP, so gradient AP equals to 11 minus 3 over 6 minus 2, which comes out to be 2. Then I'll use the fact that the radius and the tangent are perpendicular. So the gradient of the tangent is equal to minus 1 over the gradient of AP. And finally, I'll find the equation of the tangent, y equals mx plus c. I know that the gradient is minus a half, so y equals minus 1 over 2x plus c. And to find c, I'll use a point on the tangent. The only one I know is 2, 3. So 3 equals minus 1 over 2 times 2 plus c will give me a value of c of 4. Hence, final answer, y equals minus 1 over 2x plus 4. For question 21, I'll rearrange the first equation to get x on its own. So x equals 2y plus 3. And then I will substitute this blue equation to the second one. This will give me 2y plus 3 squared minus y squared plus 2 times 2y plus 3 equals to 10. Now we'll expand and get 4y squared plus 12y plus 9 minus y squared plus 4y plus 6 equals to 10. Then I'll take everything to the left. 3y squared plus 16y plus 5 is equal to 0. And now we'll factorize 3y plus 1 times y plus 5 is equal to 0. Hence, y is equal minus 1 over 3, or y is equal to minus 5. And if I substitute these values into the blue equation above, I'll get x equals 2 times minus 1 over 3 plus 3. So x is 7 over 3. Or x equals 2 times minus 5 plus 3. So x is equal to minus 7. Final solution, x equals minus 7 with y is equal minus 5. Or x equals 7 over 3 with y equals minus 1 over 3. For question 22, part A, I have point A with coordinates minus 3, 2. I need to find the image under the following transformations. Now the first one is a translation by 3 units down, and the second one is a stretch along the x-axis by a scale factor of 2. So in the first one, I'll subtract 3 units from the y-coordinate. I'll keep the x the same, so it's minus 3 minus 1. And for the second one, I'll multiply the x-coordinate by 2 and keep y the same. So I get minus 6, 2. For part B, I have this sketch. I have a graph of g of x and a point with coordinates pq. Again, I have some transformations on this point. The minus outside the function is a reflection on the x-axis. The minus c inside the bracket is a translation of c units to the right. Hence, I will add c units to the x-coordinate and get p plus c. And I will change the sign of the y-coordinate. So from q, it will become minus q. For question 23, I'll start by subtracting the 2 fractions inside the bracket. Now, the denominator of the first one can be written as x minus 6, x plus 6, and then the second one will stay the same. Now, I'll multiply the second fraction by x plus 6. So, if I merge them and make them into one fraction, denominator is common. And then at the top, I've got 20 minus 2 times x plus 6. Now let's expand the top. 20 minus 2x minus 12. Denominator stays the same. So if I simplify, I'll get 8 minus 2x over x minus 6, x plus 6. So now I can carry out the multiplication as well. 8 minus 2x over x minus 6, x plus 6 times 1 over 4 minus x. I'll factorize the numerator of the first fraction. So 2 times 4 minus x over x minus 6, x plus 6 times 1 over 4 minus x. I can cross out the 4 minus x. Hence, I'll be left with 2 over x minus 6, x plus 6. Now you can expand the denominator if you want, but this is not considered more simplified than the one given here. In question 24, I have a cone and a sphere. I cut the sphere into 2 hemispheres, and I also cut the cone and connect the hemispheres to each of the part of the cone, the result is shape A and shape B. I'm given that the volume of solid A is 6 times the volume of solid B, and I need to find an expression for H in terms of K and R. So I'll have to calculate the volumes of A and B using the volumes for the cone and the sphere, which are the following. Let's start the volume of A, which is equal to the volume of the large cone minus the volume of the small cone plus the volume of the hemisphere. The radius of the large cone is KR and the height is KH, so its volume is 1 over 3 pi KR all squared times KH minus the volume of the small cone, which has a radius R and height H, so 1 over 3 pi R squared H, plus the volume of a hemisphere, so 1 over 2 times 4 over 3 pi R to the power of 3. Let's simplify 1 over 3 pi, and then I'm going to have K to the power of 3 R square H minus 1 over 3 pi R square H plus 2 over 3 pi R to the power of 3. Let's proceed to the volume of B. This is equal to the volume of the small cone plus the volume of a hemisphere. So this is equal to 1 over 3 pi R square H plus 2 over 3 pi R to the power of 3. 2 over 3 because it's half of 4 over 3 pi R cubed. So now I can use this statement to create an equation and rearrange it to get to the final result. So VA equals 6 times VB. So let's just copy everything from above. I'll keep the left hand side the same and expand the right hand side. This will give me 2 pi R square H plus 4 pi R to the power of 3. I will then multiply everything by 3 to get rid of the fractions. So I will have pi K to the power of 3 R square H minus pi R square H plus 2 pi R cubed equals to 6 pi R square H plus 12 pi R cubed. I'll take all the terms with H on the left hand side. These are the terms with H, and everything else keep it on the right. So pi K to the power of 3 R square H minus 7 pi R square H equals to 10 pi R to the power of 3. I will factorize the left hand side and get pi R square H times K to the power of 3 minus 7 equals 10 pi R to the power of 3. So H is equal to 10 pi R cubed over pi R squared times K to the power of 3 minus 7. I can cross out the pi with the pi and also the R squared with R squared at the top. I'll be left with R. So final answer, H equals 10R over K to the power of 3 minus 7. For question 25, I know that AB is equal to A, BC is equal to B, and DM is half of B. Now AK to KB is lambda to 1, so AK is lambda and KB is 1 minus lambda. Similarly, CL to CD is mu to 1, so CL is equal to mu and LD is 1 minus mu. Those are fractions. And I'm given that KLM is a straight line. I'm also given that the ratio lambda up to mu is 1 to 2. That means lambda over mu is 1 over 2, which means that mu equals to 2 lambda. And now I will use the fact that KLM is a straight line, which means that I can create two of the following three vectors, KL, LM, and KM. Once I do that, the ratio of the A's and the B's must be the same because it's a straight line. I'll proceed to find KL and KM. So KL is equal to KB plus BC plus CL. Now K and B is 1 minus lambda of A and B. BC is equal to lowercase b, and CL is a fraction of C and D, and this fraction is equal to mu, so plus mu CD equals 1 minus lambda A and B is equal to lowercase a plus b plus mu times, and then C and D is equal to minus a. It's the same length but in different direction. And if I expand now, I'll get a minus lambda a plus b minus mu a. I'll replace mu now with 2 lambda, so a minus lambda a plus b minus 2 lambda a, which simplifies to a minus 3 lambda a plus b. And if I factorize the a, I'll get a 1 minus 3 lambda plus 1 b. There's a reason I'm putting the 1 there. Now let's find Km. This is equal to Ka plus A and D plus Dm. Ka is lambda times Ba plus A and D, which is equal to lowercase b, plus Dm, which is half of lowercase b. So this is equal to lambda. Ba now is AB in the reverse direction, so it's minus a plus 3 over 2b, and if I simplify, minus lambda a plus 3 over 2b. Finally, as I said before, the ratio of the coefficients of a, which is this one over this one, must be equal to the ratio of the b's, which is the 1 and the 3 over 2. So 1 minus 3 lambda over minus lambda equals to 1 over 3 over 2. Let's cross multiply. 3 over 2 minus 9 over 2 lambda is equal to minus lambda. Let's get all the lambdas on one side. 3 over 2 equals 7 over 2 lambda. So lambda is equal to 3 over 2 divided by 7 over 2. This will give me 3 over 7. And because mu is equal to 2 lambda, this will be 6 over 7.